Speaking. I will help him since I'm here. Okay. Good afternoon, ladies and gentlemen, and you are welcome to the part 2 of our panel, Science and the Humanities in Africa, Interdisciplinary Perspective, part 2. And we have the chair for this afternoon, which is the co-organizer with me, Mr. Iskilu Bolahan Mustafa. I don't know whether he can hear me. Okay. Good afternoon, Mr. Arojinle. And we have 4 presenters. The first person is Oluwatoyin Gladys Koshofa. She'll be speaking to identification of indigenous explanation of selected biological concepts in senior secondary schools in Ibadan. Number 2 presenter, who is also with us here live, is Mr. Adeniyi Michael Adeduyigbe. We'll be speaking on transforming physics concepts into Yoruba poetry. The other person is the theory of everything, the ultimate tool for interdisciplinary research study built using Odwifa by Mustafa Biodun. Okay, you know, Arojinle is also Mustafa Bolahan. Sorry, I'm making a mistake. Mr. Mustafa Biodun, good afternoon. Mr. Arojinle is here now. He will preside.
Yes, good afternoon. Thank you.
You are welcome. We would love to see your face when it's time for you to present. We have the third presenter, the fourth presenter, integrating African indigenous knowledge system in chemistry education, a storytelling approach. Each of the presenters will have about 10 to 15 minutes to present, and we'll continue the proceedings. So you are free to share your slide. Just tell them to give you the permission. You can hit the ground running. Good afternoon. So we'll hand over to Ms. Oluwatoyin Gladys Koshofa of the Palmet Public School in Chicago. Or am I correct, ma? In Chicago?
Yes, you are.
All right. Kindly share your
slide. Good morning, Dr. Omilani. Good morning, everyone.
Good morning, ma.
Okay, so
share your
I am
slide first.
requesting to share it.
So you can hit the ground running.
Okay, so I am sharing the slide. I don't know if you can see. Can you see my slide, Dr. Omilani?
Not yet. All right, it has come up.
Not...
It has come up now.
Okay. Okay. The chairman, sir, all lecturers present, all colleagues present, good morning to you all. My name is Dr. Koshofa Oluwatoyin Gladys from Calumet Public School, United States of America. And I'm here to make a paper presentation titled Identification of Indigenous Explanations of a Selected Biological Concept in Senior Secondary Schools in Ibadan life. It is a natural science which is related to the study of live beings, including their structures, their functions, origin, maturation, as well as their distribution. Its study helps students to understand a better understanding of the world in its natural form as well as its processes, how life evolves, survives, and changes, the interaction between cells and organs, the interaction between living organisms in relation to their environment. Biology such as genetics, embryology, amongst several other subjects. Without an adequate knowledge of biology, it would be absolutely hopeless trying to improve on the ever-growing fields of medicine, genetics, earth. Hence, no student intending to study some of these courses would be able to do so without obtaining a good grade at the senior secondary school certificate examination. In spite of the relevance and position of biology, students' knowledge of these subjects has been recorded and observed to be poor over the years. And this has been attributed to a mismatch and disconnection between their indigenous knowledge and what is learned in the school science classroom. That's according to Martin Dyke and Ramdani 2024. This mismatch has also been revealed from the Chief Examiner's report for WAEC 2016, which indicated that the topic cell and its environment appears to be an unpopular topic among students who sat for the examination in that year. This is because many of the students who attempted questions from the topic did not answer the questions correctly, and the few would perform below average. In addition to this, the Chief Examiner's report for WAEC 2018, 2019, and 2023 indicated that candidates who attempted questions from the topic cell and its environment had poor deductive reasoning and were unable to provide corresponding and convincing answers to questions. And this may also be due to lack of indigenous knowledge in that learning content. Ugwa in 2015 stated that the neglect of the child's culture in relation to science goes a long way in affecting their learning content and learning outcomes in science. According to Martin Dyke and Ramdani 2024, the disconnection between indigenous knowledge and Western science is a huge factor that is responsible for poor learning outcomes in science. And they went ahead to further describe the westernization of the curricular content in a non-Western science classroom as being apartheid, which makes it more difficult to achieve meaningful learning in science classroom. Fasasi 2017 affirmed that neglecting the wherein students and teachers do not embrace indigenous resources from an indigenous background of the students accounts for poor learning outcomes in science. It is on the basis of the foregoing that Martin Dyke and Ramdani 2024 streamlined the reasons for undesirable learning outcomes in science to the inability of the science teacher to practice situated learning, wherein the indigenous knowledge and practices that are relatable to the students' immediate environment is brought into the classroom to further help students achieve meaningful learning in science. And this consequently goes a long way in affecting learning outcomes in science. In support of these views, it is also worthy to note that emphasis on activity-based teaching and learning using locally sourced materials, Federal Government of Nigeria 2013. This implies that the teaching and learning of science is expected to be environmentally and culturally responsive. Unfortunately, this is not the case we have in Nigeria, as we still practice Western education in all aspects of science, neglecting the fact that teaching and learning of science can be rooted in the indigenous knowledge and practices that are peculiar to the society where science is taught. This means that in the society where science is taught, whatever indigenous knowledge and practice that are relatable to that learning content should be infused into the Western science classroom, but this is not what is happening in our classrooms in Nigeria today. It is therefore against this backdrop that the researcher embarked on the identification of indigenous explanations of a selected biological concept in senior secondary schools in Ibadan, Nigeria. Owo and Mosimeche 2004 defined indigenous knowledge as a local and community-based system of knowledge unique to a particular society or culture that developed as the culture evolved over several generations of inhabiting a particular ecosystem and encompassing knowledge commonly known within a community of people. Research has shown that when indigenous knowledge is infused into the science classroom, desirable learning outcomes are achieved. For instance, Zinyaka 2014 observed that infusing of indigenous knowledge and practices into the physics classroom impacted the learning outcomes of students in physics. Similarly, the reports from the research conducted by Joseph and Elrina 2009 indicated that when indigenous knowledge and practices were infused into the teaching and learning of biology, it helped to increase the retention of abstract concepts in biology. One research question was raised for this study. The study also covered 86 Yoruba elders from 4 randomly selected local government areas in Ibadan, Oyo State, Nigeria, and cell and its environment, which is a major topic with relevant content, was selected from the senior secondary school biology curriculum. The theoretical framework upon which this study was grounded is the border crossing theory propounded by Aikinet and Jegede 1999. This theory holds the view that learning school science demands that students have to cross boundaries that exist between the indigenous context of their society and the cultural context of the school science. This theory is related to this study, being that the cultural borders which students experience in the science classroom are invisible to the science teacher. So during the teaching and learning cycle, the teacher is able to identify the cultural border that the students experience during the teaching and learning processes in the school science culture, and then consequently help to remediate where there is a contrasting and conflicting idea or knowledge when it comes to the child trying to cross these cultural borders into the school science culture. The study adopted the qualitative research design of the interpretive approach, and it was also carried out using an ethnographic research design where data on common indigenous knowledge and practices were generated from Yoruba elders through focus group discussion. 2000 thematic method of data analysis, which has given a better explanation to indigenous knowledge and practices, conventional science explanations currently unavailable but are likely to be developed, direct link of Western science to indigenous knowledge and practices and its varying perspective, contradictory views to science, which is the 4th one. The results from this study showed that there are indigenous knowledge and practices in the teaching of cell and its environment. However, they have aspects in them that conventional science gives better explanation to, and also it shows that it also revealed that there are direct links between indigenous knowledge and the Western culture, knowledge and tense, which is sense has discussion fields as well as research on indigenous knowledge and practices. It is recommended that the Federal Ministry of Education formulate and implement policies for infusing indigenous knowledge and practices into science curriculum if meaningful learning is to be achieved. Educators as well as educational stakeholders should also be trained on relevance of indigenous knowledge in the process of teaching and learning. And also, the students' prior knowledge should also be explored in order to identify misconceptions therein and also remediate them in order to help students construct new and meaningful learning. Thank you all for listening.
Thank you very much, Dr. Gladys, for that wonderful presentation. So those of us online, let Mr. Rojinde continue the proceedings. Just introduce the next person and so that it won't be, since you have come, I just took over since you were not online when we started. Or let me introduce the person, then you take it from there. The next presenter is here with us in Lagos. Stop sharing your screen, Dr. Gladys.
Okay.
So the next presenter is here with us in Lagos, and his name is Mr. Michael Adeduyigbe, and he'll be presenting the topic titled Transforming Physics Concepts into Yoruba Poetry. You have the floor, sir.
All right, good afternoon, everyone. Thanks to the chair and the co-chair of this panel. It's great to be here. So this afternoon, I'll be presenting on transforming physics concepts into Yoruba poetry. Now, the idea stemmed from my encounter with the Chinese who I boarded the train last year. And based on our interaction, I realized that this man could not speak English, but to my surprise, they are the one controlling the train station in Nigeria. So that drives me further to look at some of those countries that have been using mother tongues to teach in their country. Countries like Finland, Germany, China, not just at primary school level. Here in Nigeria, we operate based on the curriculum that we can use it for the lower primary. But we are not looking at it. For students to really understand this concept of physics, can we bring it to their culture? If they are Yoruba, can we use Yoruba to teach them? If they are Igbo, can we also use Igbo and Hausa? And we all believe that physics is abstract and often hard for students to relate to. Now, language barriers make it even harder for students in Yoruba-speaking areas, especially when we begin to look at some big terms and students find it difficult to understand, even at tertiary level. And this also brings a reminder to me that while in secondary school, we were told not to speak vernacular. So when the physics teacher is in class, even though you have something that is not clear to you, you are not expected to speak in Yoruba or your language. So that also brings some of us not to ask some certain questions. So Yoruba poems and proverbs talk about everyday things like motion and force in familiar ways. Such one of the examples is Lala Toroki, Ilelumbo, and some other ones. Using the local language in teaching helps students understand physics better. This study uses Newton's law to show how physics ideas can be taught through Yoruba poetry. So what I actually look at is how I can use Yoruba poetry in explaining Newton's laws of motion, which I also believe that after the conference, I will also be looking at how Yoruba can also be used to explain other concepts. So the power of language in physics learning. Grounded in culturally relevant pedagogy, this study uses Yoruba poetry to connect physics learning to student cultural context. So what this study based on is how we can connect students learning physics with their cultural heritage, with what they've already familiar with. Then Jacobian theory shows that how something is said, like through poetry, can make physics more engaging and easier to understand. So if physics is being taught with a language which the learners are familiar with, and in the Yoruba-speaking environment, this will make it more clear to them. And it's also believed that Yoruba poetry helps turn abstract physics ideas into lines students already relate to, improving understanding and memory. So that will take us to some of the poetry I came up with that can be used to explain Newton's law of motion. And the first one is, so for Newton's first law, I will say it in Yoruba and also in English. Bí kò bá sí ipá, àgùntàn kì í kọ lóko. Bí afẹ́fẹ́ kò bá fẹ́, ewúrẹ́ kì í rìnrìn àìnídìí. Ohun tí kò ní ipá kì yóò yí ipò rẹ̀ padà. What that means in English is, if there is no push, the sheep does not stray into the farm. If the wind does not blow, the goat does not roam aimlessly. That which has no force acting on it does not change its position. Now, what this means in physics concept is an object remains at rest or in uniform motion unless acted upon by a force. So, using this Yoruba poetry to teach students, not just students, even people outside the four walls of classroom, because initially they are familiar with àgùntàn, which is sheep. They are also familiar with wind. They are familiar with the farming occupation. So if we are taking physics out of the classroom, they will be able to understand what we are saying. And for the second one, bí ipá ṣe wúwo sí, bẹ́ẹ̀ ni àgbọn yóò ṣe yí kíákíá. Bí àgbọn bá ṣe wúwo sí, ni ipá náà gbọ́dọ̀ pọ̀ sí. Bí ẹrù ṣe ń pọ̀ sí, ni ipá ṣe ń lágbára. The English translation of this is, the heavier the force, the faster the coconut rolls. The heavier the coconut, the greater the force required. As the weight increases, so must the strength increase. And this is actually talking about the idea of the acceleration of an object depends on the force applied and its mass. This illustrates Newton's second law of motion. So using this idea, it is believed that any student, especially even though those that have not been to the four walls of the classroom, because if you are on the mountain and they place the coconut there, they know that it will roll down. The only thing they only need to know that it is the force that is acting upon it. And the greater the force as well, and the greater the mass, the higher the force required. And to the last one for this is the one that explains the Newton's third law of motion. Bí ọwọ́ bá lu apá, apá á dá padà lẹ́yìn. Bí omi bá lu etí òkun, òkun á gbà padà. Iṣẹ́ kì í lọ́ọ̀kan nìkan ṣe ṣoṣo. Ìbáṣepọ̀ ló dùn láyé. So what this is saying is, when the hand strikes the arm strikes back. When water strikes the shore, the sea returns it. No action stands alone. Life is a circle of response. So this can be used to explain to others, because even those that have not been to the world, they know that if the hand strikes the arm will strike back. And when water also strikes the shore, the sea will return it. So what we only need to let them know that at this point, what is actually applicable is the Newton's third law of motion. So what are the pedagogical application and impact of Yoruba poetry on physics? The first one is Yoruba poetry connects abstract physics concept to students' everyday experiences, improving understanding and interest. Then the second one is its metaphor and rhyme support memory and meaning making. So this will not be difficult for students to learn and to also master. Even some of them can turn it into songs and they begin to re-echo it. Using indigenous language in science affirms identity and promotes inclusive. This will also help people who are not even familiar with English language to also know that physics can also be brought to us. In conclusion, integrating Yoruba poetry into physics makes abstract concepts relatable and memorable. It promotes inclusive, culturally relevant learning and challenges the marginalization of indigenous knowledge. What are the recommendations I make from this study? Teacher training and sensitization. There is a need to train teachers, especially those in physics, on
this. Okay. Oh. Hello, Mr. Arojinde. I said you are to chair this panel. So I believe you can continue, introduce the next two speakers. Sir?
Yes.
Introduce
I
the
can hear
next.
you. I can hear you. So
I said
the
introduce
next
the next two
paper, the
speakers.
next speaker is presenting the theory of everything, the ultimate tool for interdisciplinary research and studies, built using the ODIFA. And this paper was presented by Mustafa Adedejibani. You have.
Okay, thank you.
Would you share your slide first, sir? I would love to see you in person.
Yes.
Your video should be on.
Yes, it's video.
Yes, thank you. Mr. Chairman, sir, I greet all the panelists. I'm presenting on the theory of everything as an ultimate tool for interdisciplinary research and studies within the UDIFA. The IFA Internet is the other name for this tool that I'm presenting. So it is also known as IFA or IFA Mathematics, and is a solution to the problem of the theory of everything in physics, which seeks to unify all theories and models of the field into a single theoretical framework. This a lot of scientists have been trying to develop it for many decades now, including the popular. So the model is like a single language that can be used to study all areas of physics. Physics, as we have it today, is fragmented. It has different silos or different branches or subfields. So scientists have been trying to look for a single, a single framework that can connect these diverse areas of physics. So this problem is what is called the theory of everything, theory in physics. Is a research area in physics. So when I was trying to seek the solution to the problem, so I discovered that in African knowledge systems, in our native knowledge system, we don't our ans- our ancestors did not study any field using the siloed approach. Any field that they study them, whether it is physics, what we call physics now, chemistry, and different areas of science and non-sciences, they study them, they develop them using a holistic approach. So they don't have the problem of the theory, what we call the theory now, because they never fragmented knowledge into different aspects. And the Ifa of Yoruba people, which is known as the voice of Olodumare, Olodumare ní èdè Yorùbá, is our own native information and education system in Yoruba culture that contains knowledge on all areas, physics, chemistry, different areas. So it's a compendium, like an encyclopedia of different fields of knowledge. So I discovered that IFA is a solution to this problem because physics in IFA is not fragmented. We use the ODIFA, the language of IFA, to study any field of knowledge, physics or any other field. It's not siloed. We are not going to encounter the problem of theory because physics is unified in IFA. The same thing applies to chemistry. The same thing applies to all other disciplines, even in the arts and others. So IFA offers a deeper level of integration than the current internal model and unifies all disciplines of knowledge, which makes it a vital tool for interdisciplinary research. The current internet that we are using today is a global network of computers all across the world, a massive network of computers. However, I discovered that the internet has had also been developed in ancient Africa, especially in Ile-Ife by the ancestor that we call Orunmila. And that is what it is known as Ifa. The Ifa is an interconnected systems where the mathematics is used to connect different realms of knowledge together. So when we study the Ifa system, we're going to discover different areas of knowledge, which are symbolized using different deities, which we call Orisha in Yoruba. And the whole system is interconnected and internetworked together using the math that we call Ifa codes. So the problem that this system, the Ifa Internet, the solution to the problem of the theory seeks to solve is to unify knowledge across all disciplines and fields, and to enable us Yoruba and Africans to use our native language and culture to develop knowledge and also acquire knowledge. The system is not just we are not just after translating knowledge, scientific knowledge in English to Yoruba, even though that is also a very vital aspect of knowledge and development in Africa. We want to use the system to develop our own native knowledge system where we use our culture, because the approach that the African approach to knowledge development is different from the Western methods that are mostly reductionistic and materialistic in nature. While the approach in Africa is holistic, and the approach of Ifa as a key African indigenous knowledge system is highly mathematical and systematic. So that's one of the major things we are introducing in the project called the Ifa Internet. So as a solution to the problem of knowledge unification, interdisciplinary research and studies. So before before now, many people have tried to unify knowledge across all areas of physics, also across diverse fields. So previous solutions to the problem of the theory, there are a number of them. But let me start from other fields. Like in philosophy and logic, the popular mathematician Leibniz had tried to develop a mathematical language that can be used to study any field of knowledge. He called it Characteristica Universalis. So the work it lies in the domain of logic, interdisciplinary too. So the approach in IFA is energy-based. It's an energy-based approach. So before now, the different scientists have tried to develop an energy-based approach that can be used to unify, integrate diverse disciplines as an interdisciplinary tool. Popular example is the field of energeticism, which is also called energetics in some certain context. So the field of energetics was founded by the Nobel laureate of chemistry, Ostwald. So it was not established in the field. So he was trying to use energy according to the energetics movement. They believe the energy is the essence. They regarded energy as the essence of reality, not atoms. While the other part of the divide, the atomists, they regard atom as the fundamental basis of reality, not energy. So a lot of debates were held in Europe between these scientists across both divides, and because of the because of the lack of experimental evidence for
we have just a presenter after him, so we can just add 5 minutes more. so that it could finish.
Okay.
Yeah. We just have a presenter.
Okay. Thank you, sir. So the energy-based approach. So because of lack of experimental evidence for the energy-based approach, more evidence was found for the atomic theory of model of reality and also quantum mechanics. So the energy-based approach of Oswald and other proponents of the idea was Mark, the popular physicist, and Mark. So the whole model was rejected because of the experimental evidence for the atomic theory. So, however, I think the major problem why the energeticists then they could not develop the model that they thought they could prove their theory using experiments. While it's actually in IFA did not solve this problem of looking for the basis of reality using experimental method. IFA used mathematical method because in IFA, in African indigenous energy system, reality as we see is a mathematical construct. It's a sacred divine aspect, but it's actually mathematical. So before we look, we go deeper into trying to understand what constitutes reality. Mathematics is actually the basis. It's not provide an experimental evidence for the theory. So these are the other approaches for the using the solutions to the problem of theory. So there's no time to go into them. So let me go to the using IFA as a bridge. So we have the old IFA of Yoruba people is a computer, is an ancient computer that was developed by Orunmila. I regard it as the first computer system that was developed because it actually predates abacus and other ancient computer systems. So this is the mathematics of some of the core of the IFA. I'll go into the details here. So I did a comparison of a IFA computer. IFA is a bridge. Basically, in this research, we got IFA as a bridge that connects all realms of knowledge together. So the core of the system, the core of the computer is what it's called. So we can find anything only the kernel, palm kernel tamando. So about compare our computer system with the IFA system, we're going to see a lot of parallels that is going to really show us that IFA is actually a kind of computer as a statement of fact, not just as a tactic. So if you compare the kernel of an OS now to the kernel of Ikin, you know the palm kernel, the Ikin file also has its own kernel, its core. And if you look at the OS of the computer, the kernel of the OS is the core of the OS, which acts as a bridge between the hardware and the software of the system. So the kernel of the Ikin file is actually the core of the system, where IFA is actually bridge that links all realms of knowledge together interdisciplinary research, IDR. So that's why we call the IFA Internet the ultimate IDR tool. We regard the IFA Internet as the global network of IFA computers used to integrate and unify all fields of knowledge in the IFA binary system of education. So this slide shows the more of the comparison. So you have the Ikin kernel. The Ikin kernel is the object that IFA basis for IFA consultation versus OS kernel. So this Ikuro is different from Ikin. Ikin is the section of boundary that produces Ikin is different from the one that produces Ikuro. So this is the kernel of the OS. It's just a bridge. The same function that the kernel of IFA, the Ikin kernel also does for the IFA system as an ancient computer. So you have the IFA as a tech, as a computer. You have the Ikin kernel versus OS kernel. So this is the Ikin file is also the nuts. So this one that is a pro used to produce palm oil. So you can see there are many parallels in the binary system, in our computer system, modern computer system, and the IFA Ghana system, we're going to see a lot of parallels and many other parallels, such parallels, show that science and technology is actually very ancient, and that IFA is an ancient computing technology. So the proposed model of the operation of the IFA as the ultimate ideal tool is that we are looking at, if you look at similar papers of this sort that are proposed an ideal framework. So we have the different ideal university. So the ideal university in this case is the TU University, where is an institute of IFA mathematical sciences. That's where mathematics is used to study all physical knowledge in a holistic and integrated manner. So that's actually the IFA education system. It's different from the Western education system. So that's the things that I feel. Thank you.
Thank you, Mustafa Abedon. We'll take the fourth and the last paper. Please, you can share your screen now, sir. We'll take the fourth and the last paper for this session, and it's titled Integrating African Indigenous Knowledge System in Chemistry Education, a storytelling approach, and it will be presented by Mr. Bamidele Emmanuel Tijani from the University of Lagos. You have the floor, sir.
I think Baba should stop sharing. Hello. Let Baba stop sharing so that the next person can share. Please stop sharing, sir, Mr. Mustafa, so that the next person could share. Okay. You can share your
screen. Good afternoon.
Mr. Mustafa, share your screen. Mr. Bamidele, share now. Share before you start.
Screen now, please. I've shared my screen.
Yes. You can go on now.
Yeah, good afternoon, everyone. Good afternoon to the panel. My name is Bamidele Emmanuel Tijani, and I will be presenting on the topic that says integrating African indigenous knowledge systems in chemistry education and storytelling approach. So to start with, what are the challenges of chemistry? Let me first say that one of the things that drives this study, for me to carry out this study, is that having been a secondary school teacher for more than 7 years, I realized that in the first 2 years of my career, I realized that students often struggle with understanding some aspect of chemistry. And to me, I believe that
is back
related to how the students boil water at home, when they are cooking food and they want the food to dry up, how they open the pots so that there can be evaporation. To carry out this study, and in the understanding of natural words, and that is according to Ugo 2016 and Camille 2000, often perceived as abstract and inaccessible, particularly in African educational context. Yes, there are so many students that fear chemistry. In fact, as a matter of fact, when I enter class, I ask students, what's the subject you hate most? Most of them will just say chemistry, and why are they like chemistry is so much complex? And the reason for this is because of the traditional teaching method, which has been used in teaching chemistry. And this traditional teaching method often focuses on theoretical content, creating a kind of disconnect from student cultural experience. What if we bring in some cultural experience, some knowledge, some indigenous knowledge that the students are already familiar with, and we use it to teach chemistry? How do you feel the students are going to perceive chemistry? Will their perception change? Will their achievements change? Will their understanding of that chemistry concept actually change? And in order to bridge the gap, indigenous knowledge system can actually bridge this gap. This is because we can have a culturally responsive approach when we integrate the indigenous knowledge system into chemistry. education. So integrating IKS into the curriculum offers a promising pathway to bridge the gap between the theory and the practice. This is according to Ford and Kerr 2009 and Holadejo et al. 2022. And it also makes chemistry relatable, like it aligns chemical principle with familiar cultural practices, and it transforms abstract concepts into concrete and relatable experiences. Another thing is that it promotes inclusivity in education. Like the adaptation of IKS into chemistry instruction can actually foster an inclusive and equitable educational system. Thereby, it makes traditional practices to be valued, and at the same time, it makes chemistry to be more simpler to the student, thereby expanding their understanding of scientific principle. Also, another thing is storytelling, like narrating, relating chemistry concept to some of the stories that the students are actually familiar with that can bring about understanding. It also creates deeper understanding, then it enhances engagement. The impact of IKS on achievement, yes, there's a lot of studies that has actually that has been done regarding that, and it has been proven that chemistry, integrating IKS into chemistry instruction actually increases student academic achievement. It makes them find chemistry. It makes them enjoy chemistry. It makes them relate chemistry to their environment, like to their culture. Therefore, they find joy in doing it, and it brings about positive attitude. So for this study, the research design that I adopted for this study is a multiple case study synthesis, uh, and I integrated quantitative, qualitative, and mixed method research on indigenous knowledge system in secondary school level chemistry and physical science. The research actually follows the principle of Yale's 2018 Protocol for Aggregate Case Study Analysis, and it aims to identify cross-case patterns without seeking literal replication. So I try to carry out the study that has been synthesize the study that has been done in African context in the past and carry out the cross case pattern about the study. And the sampling strategy, I use a maximum variation sampling strategy. And this was used to ensure the synthesis speaks to a broad spectrum of indigenous chemistry learners. 10 peer-reviewed studies from 2016 to 2025 was actually were purposefully selected to cover 4 African sub-regions. So the regions include Nigeria, Ghana, Zambia, South Nigeria in the west, then Zambia in the central, south in the southern we have Zimbabwe and Namibia, including both urban, rural, public and private school content. So these studies are both carried out under the urban, the rural, the public, the private school contents in order to ensure that inclusivity is maintained. So the case and the context. The 10 studies uh, span 4 African countries, like I said, and the table below actually summarizes it. As you can see here, we have the first study, we have the study of Chikwadis and Jakulula 2025. We have those studies as you can see on the screen. So how do I extract the data? Data extraction and standardized Excel template. And this captured citations, publication year, country, educational settings. And the reason for this independent extraction is so that in order to minimize bias and there can be comparison between the studies. Then a systematic quality appraisal. How do we carry out do I carry out the systematic quality appraisal? Each study actually underwent systematic quality appraisal using the mixed method appraisal tool. So this mixed method appraisal tool was developed by Hackipart et al. 2021, and that was what follows the quality appraisal. What this study actually followed in appraising the outcome of the study. So it measures the sampling, the validity of the outcome, the control of full funders were actually evaluated for quantitative design. The clarity, the rigor, the depth of analysis, and researcher flexibility were assessed for qualitative studies. The mixed method research focused on coherence and integration between qualitative and quantitative strands. All the 10 case study achieved a score of 75% or higher on the MMAT, that the mixed method appraisal tool, which indicates that and narrative description. So those areas that were extracted were the qualitative and the narrative description of the studies. Then what follows in the second stage is a priority code which was organized under 4 dimensions. The first one is the pedagogy, the indigenous knowledge chemistry linkage, the engagement, interest, and teacher development. Then qualitative aggregation. So the qualitative studies in the second stage, qualitative outcomes were aggregated and compared across cases to identify patterns and effect size. So the quantitative outcomes were aggregated to actually look at cross pattern between those studies. And this facilitated a holistic interpretation of how culturally grounded storytelling reach strategies impact secondary school level chemistry education. So cross-case comparison was done between the was mapped for each study's instructional design, the high-K practices, the engagement outcomes, and teacher development impacts onto the 4 analytical dimensions, detecting recurring patterns. So in order to look at the recurring patterns, then these are the things that were found out, the interpretation from those analysis and the coding. The sentences reveal consistent and statistically significant gains in student achievement, meaning that if IPS, indigenous knowledge system, are actually incorporated into teaching and teaching of chemistry, is going to actually increase student academic achievement in chemistry. We found this. This was also found in the study of Kaleba and Amusde 2020, which reported a jump in chemistry academic achievement score of students from approximately 39 to 60, with a significant the p-value to be 0.29, demonstrating that embedding local socio-economic activities can nearly double students' conceptual mastery. So if chemistry is related to the students' cultural context, it will make them to actually remember very easily, in the sense that their cultural concept is something that they have been used to right from when they are giving birth to. They've been brought up, they know the culture, they understand how it works. So relating it to chemistry will make them retain the understanding of it. Then another thing is that it enhances engagement and interest. So it increases cognitive engagement, it increases emotional engagement, it makes the student more engaged in the lesson, both the cognitive, the emotional, and the behavioral engagement. That is, how do the students behave when they hear the chemistry concept? Did they see it as if it's something that they cannot know? Did they see it as something that is very difficult for them to comprehend? Then from those 10 case studies also, I identified teachers' development and challenges, certain challenges. The first thing is understanding the principle of IKT. So the study actually, the sentences revealed that teachers showed understanding of IK principles and development and deploy student-centered method despite resource and time constraints. So in all these cross pattern of the study, I identified that despite the fact that resources and time was not there for the teachers that participated in the study. Despite that, they still make sure that the high case system is used. Then cultural brokers. According to the study of Arnold 2002, it documented growth in teachers' pedagogical context knowledge and cultural knowledge when co-designing lessons with elders. That is, the teachers relate to elders to develop an approach whereby it can they can come up with something that will be used in teaching the students and relate the lesson to their cultural context. So they went to meet the headers and were able to actually get some knowledge and able to fill the gap between the students' understanding of chemistry concepts. They were able to identify the gaps, address the gaps of difficulties in students I address the difficulty of students in chemistry. Then translating procedure, then we have institutional support was actually needed. One of the things that was identified is that institutional support is needed. Like one of the presenters said, during our secondary school days, one of the things that actually made it difficult for us to learn is that at times they prohibit us from speaking Yoruba. For instance, maybe you are talking to your peers in Yoruba, you are being prohibited. And with that, there are certain concepts that if we really want the students to understand, we need to relate it to their cultural context, like to their language. How is this thing put in their language? Okay, okay. If I want to understand the word temperature, okay, instead of using the word temperature, why can't I just say okay? When we say okay, it can bono, that is something is hot. That's the meaning. Why can't I relate it like that? Imagine a student that doesn't, and the problem with this is even that some of those students, they don't understand the English, they don't understand the Yoruba, and because of that, for them to even comprehend the concepts will be very, very difficult. And another thing that IKS does is that it deepens understanding and engagement of students. As you can see, it enhances conceptual grasp, significant achievements. Then there's need for the role of teacher and professional development. One of the things that was found out in the study is that um, teachers' superficial incorporation of indigenous elements often lead to due to limited training, yielding negligible attainment gain. This highlights the need for more than just a passing and a passing out to cultural elements. Deep integrations require specific skills. Then another thing is that there should be a robust professional development on teaching how teachers can actually relate chemistry to cultural context of the students, then use storytelling approaches in teaching chemistry. Then what are the implications of this study? The one for the policymakers and curriculum developers should formally integrate IKS and storytelling modules into secondary school chemistry syllabuses to narrow the engagement gap. Then teacher education, there should be educational programs that are going to train the teacher on how to actually effectively use the IKS. The problem is not that some of those teachers are not using it, but the problem is that they are not using it the right way. The right way is supposed to be used. Then resource allocation. Education authority should allocate dedicated instructional time, resources such as mobile laboratory kits and community lighting. That is, there should be collaboration between the community and the school environment so that a cultural context can successfully be integrated into teaching and learning. The future research should integrate longitudinal design to assess the durability. And I would like to speak on this. While trying to carry out this study, there are some motivation, there are some questions that keep on springing within me, in which I actually plan to carry out another study on this. Probably it's going to be an experimental study to actually look at how this thing really works in the secondary school content. Thank you for listening. And I'm open to question if there's anything like that. Thank you.
Well done, Mr. Bamidele Emmanuel. Well done. I really enjoy your presentation. Do we have questions from the audience first?
Okay. There's somebody online that raised his hand. Olusegun Soetan. Let's take the online people, then we'll take the...
Mr. Soetan, please go ahead with your question. Mr. Soetan, are you still there?
Olusegun Soetan raised his hand. Maybe he has raised it long ago.
He's still there. Okay, maybe he's not close to his device.
He has been allowed to talk now.
So again, the organizers, so you have to recognize that those of us online, when we are muted, so for us to speak, whoever is moderating or in charge of the tech must allow us, unmute us before you can hear us.
Yes,
and by the way, I'm Mr. Olusegun Soetan, I'm Dr. Soetan. So
okay, sorry, sir. The thing did not indicate you are doctor.
That's fine. So good afternoon, everyone. So thank you so much for this wonderful panel presentation. So my name is Dr. Olusegun Soetan. I'm a scholar of African cultural studies, and one of my core area is African indigenous science systems. So the reason I'm here today, so I'm an interdisciplinary scholar, part focus on Nollywood and the rest, but this other one is one of my core areas. So I listened to the two presenters, so and then I think I have a question for them. So My question for the first speaker is, he mentioned Ikin as the core. So then I wanted to ask him if if he knew about the Okbele, because the guy who presented, the presenter on IFA. So if you are using Ikin as the core, not all IFA divination systems use Ikin, there is Okbele. Is the Okbele also the core, or how do you interpret the Okbele in that regard? So that's my first question. My second question is, you said IFA is mathematical. Yes, IFA is mathematical. To what degree? As a cultural studies scholar, I feel like IFA is more poetic in my own understanding. So to what degree do we say IFA is holistically mathematical in its composition? That's my question to you. So, and I feel like, I'm going to say this to both of you. I know you have good paper presentations, very good. The other presenter, the last presenter, so you talk about this whole idea of, you talk about the idea of culturally grounded storytelling for teaching chemistry. So I wrote that down. So my question to you is, how do you demonstrate that? How can we have culturally grounded storytelling technique for teaching, for instance, hygroscopy? For teaching, for instance, what we call, organic chemistry. How do we talk about covalent bonding? All of these different series in chemistry. Which culturally relevant story, series of them, can we use to teach this kind of topic? So I feel like your topic is good, is great, but you did not touch on a sample, specific ways of using these approaches. I feel it's too much of literature review without you actually showing us one or two ways in which this could be achieved. So far so good, brilliant papers they have. They have, I can see that they are going to be beautiful if you continue to work on them. So I want to encourage you both to keep working on your proposals, but I just feel like they are more of two literature review than actually showing us, what this can actually mean in terms of practical pedagogy. Thank you.
Can I answer the question?
Sure, sir.
Yeah.
Yes. Thank you, sir, for the comment on question.
Okay, do you want to use your slide to share? You want to show him something on the slide?
Yes, he asked the question about.
The slide is showing.
Okay, you needed the slide.
Okay.
Be fast, please. We have time to leave this place.
Okay.
Be fast,
okay,
please.
So let me quickly. So the one on the first question about Okpele. The prime IFA divination object is Ikinfa. That's the first object for divination as introduced by Romila himself. So that's the prime one. Why the next one in ranking is Okpele. So according to the philosophy of IFA, every object has its own Ori, which is known as consciousness, or its core. So for the Ikinfa, the kernel is the physical representation of that core. So that's the Ori of that Ikin. That's the energy of that. So it also has its own consciousness of Ori, or its energy, which is its core. So I believe that as an answer. Then about the extent of how the IFA system is, the basis of IFA mathematics is energy. So we model energy using infinity. So IFA is the extent is doubly infinite. It's a mathematics of double infinity, dual infinity, which we call IFA infinity. So which stands for energy. Is a composition of two opposite infinities, plus and minus infinity, which is they are going to annihilate each other. But if you are doing the operation using the same number system, we are adding 1 minus 1, that's 0, 2 minus 2, 0. If you continue in that order till infinity, you are going to have plus infinity minus infinity, and going to give us 0 or energy in this in the IFA model, and that's the core of IFA system, which the model at Ogbe. So thank you. Let me stop the.
Mr. Bamidele.
All right. Thank you very much for that wonderful question. Like I said the other time, the major reason for carrying out this study is to actually identify cultural pattern of different studies that have been carried out. So while I was citing those studies, I began to pose some questions on how this cultural context can actually be brought into chemistry instruction and storytelling approach. And I plan to actually gather those things together to carry out the study, then test it myself before I can actually push forward to be able to answer that question. I don't know if that's clarified the question from the
question. I think the indigenous knowledge system can really be used to and applied to almost all aspects of chemistry. I was formerly a chemistry teacher, and he asked how do we apply the indigenous knowledge system to, he gave hygroscopy as an example. Yoruba already has a proverb that says, "Be your back penly, ama show me." Yoruba already has a proverb on ground, "Be your back penly, ama show me." And he asked about covalent bonding. And I think in the Yoruba indigenous, since the paper also mentioned storytelling approach can be used to really answer this. Covalent bonding can be spoken in terms of sharing between two people. So we can say two boys living in a hostel, sharing the comb together, and other electrovalent can be spoken of in terms of marriage. We know that in Yoruba land, the man gives to the woman. So in electrovalent bonding or ionic bonding, one is donating electron. So the man is donating money to the woman before marriage can occur. So we have a lot of cultural significant or cultural entities that we can use to explain different topics in chemistry. I just wanted to add that. Thank you.
Okay, Dr. Omilani. I also want to contribute to...
Dr. Gladys. Dr. Gladys, could you hold your thoughts? Somebody in the room wants to make the we will now go back online. Yes, Dr.
All right,
okay, thank you.
Introduce yourself, ma.
Okay, I'm Dr. Adebusui from Olabisi Onabanjo University. So my question is to Dr. Bamidele Tijani. The way you have presented the paper, I think it should be a literature review of. I don't think it's an empirical study yet, because I wanted to suggest that you mentioned a storytelling approach. So I was expecting that what's the impact of the storytelling and the narration and all that. But from all I've gathered from the presentation, I think it's a literature review. But I think you dwell more on the indigenous knowledge system in chemistry than the storytelling. So maybe you can quickly explain the relationship of this. Is it that you are just telling us the story, how it leads, or how it's the indigenous knowledge system can be applied in the teaching of chemistry, or did you marry the two? Did you look at the literature telling us about storytelling, the importance of storytelling, or the impact of storytelling approach on the performance? I think you mentioned engagement and attitude. I want to be clearer. Then when I looked at the methodology, you said maybe you considered literature that made use of quantitative, qualitative, and mixed method. Then you now say case study. I want you to shed more light on that. Is it that you only selected studies for case studies in your literature review, or how did you go about it and all that? And I also want to those are the questions you need to answer, but my contribution is that I think as chemistry teachers or educators, looking at these panels so far that have been involved, I think we are all talking about similar things. How about we consider maybe we should now begin to pick a topic and now saying how this, and as in specifically tell us your way.
Generic.
Exactly. That
like
is,
this
if you pick,
this person brings the laws of motion.
If you
and
pick laws of
for
motion,
things that could be used to teach it.
Exactly. So that
So that we
can
developing
pick
a
it.
library.
Yes, a teacher can easily pick it and use it in the classroom. How about when someone talked about hygroscopy? Let that person deal with hygroscopy as a topic and give us the instances and the specific proverbs, because not all of us know
or
all
resources.
these things. Exactly, or resources. Exactly.
Like in your own show me what
you did something about rain. You understand? Pick what is specific topic can this address?
Yeah.
So by the time all of us collaboratively
the
work,
first presenter is working on cell and its environment in biology.
Exactly.
This person is physics, laws of motion.
So I think we should all begin to look at these issues so that by the year, at least maybe by next year, all of us would have made significant contribution that we can answer that, okay, teachers, these are what we have come up with. You can use it in the classroom. And I think this will now be like an implication of practical in our classes rather than us just coming, say that this is good. We all agree now, because I think our research is pointing to something that yes, indigenous knowledge system is good, let's pick a particular topic specifically, every one of us, and let's work with this so that this will be taken down to the classroom. Thank you.
You can go on, Dr. Gladys.
Okay, thank you very much, Dr. Omilani. So what I was going to say is very similar to what she has just said. What I was going to say is just about the same thing she has just said. Thank you.
All right, thank you. Thank you. Mr. Arojinle, I want to quickly make some remark. After I finish my remark, we can listen to me, Dr. Olusegun. Mr. Arojinle, am I allowed to?
Go ahead, sir.
So, to Dr. Gladys, I wrote this question down. I said, what makes a Yoruba elder in your selection of sample? Is it age? There must be a definition of what makes a Yoruba elder, because you collected your sample from the Yoruba elders. That's number one. I also said, if time permits, before we go, give one example of the IKS identified. Maybe internet threw us out. I was waiting for a specific example. To Babawo, I said that in my own conception, when I read your abstract, and myself and Mr. Arojinle, we read everybody's abstract. We had a meeting in my office looking at each of the abstracts. And your abstract seems so promising than the presentation, because I was thinking you will tell us about that model and how exactly it explains physics. But at the end of the day, during the presentation, I saw that you are drawing parallel between the internet and computer and the IFA system. Not actually, you made some attempts to identify the weakness of the existing model, because you said they are energy based, but IFA is mathematical based. The last presenter in chemistry, I want to say that there are so many contradictions in the methodology section, because it's as if from the results section, there is no homogeneity in the papers even selected. Some of them are in the direction of teacher development. Some of them are in the direction of treatment and having result of treatment. You know, it is very important that whenever you are using literature in form of a meta-analysis that this study is close to, there is a need to actually make sure that the papers that will be considered will be homogeneous. Several studies were captured with several focus. And the question the person asked initially about the storytelling component is not very, very clear, and it's not seen in the study. Yes. I just wanted to add a comment, the proverb that came to my head when Mr. Adeni was explaining the third law of motion, and it was Okotaba Somokbe, Lokben Somoni, you know, equal and opposite reaction. Mm-hmm. Although that proverb is talking about that Okbe is telling you the same thing. It's not actually having the same literal interpretation, but efforts could be made to actually subject it to. So I would like Dr. Gladys to answer a question. Dr. Baba, our own Baba, the only Baba in the panel, Mr. Adediji Tijani Mustafa, we also answer his question. Then eventually we will now go back to Dr. Olusegun Soetan and take his remark. Dr. Gladys, you have the floor.
Okay, thank you very much, Dr. Omilani. So basically, in each of these local governments, there is a group. There is a group called the Yoruba Elders. They call them the Agba, Awon Agba.
Okay.
So now this group, majority of them are herbalists.
Okay.
Majority of them are herbalists, and then majority of them are custodians of indigenous knowledge. More like they have stayed in that region for so long, and then they are very vast when it comes to traditional practices. And another thing I observed that must have constituted what qualifies them to be a Yoruba elder is age. Okay. So this was not a selection. Yes, this was not a selection made by me. Okay. It is something that is in existence already.
Thank you.
So how I was able to get them, how I was able to get them was liaising with the local government. Can you hear me? Hello?
No, I didn't touch it. Yes, we can hear you, Dr. Gladys.
Okay, so it was not a selection I made by myself. It is something that is in existence already. Can you hear me? Can you hear me?
Yes, I think they have a problem.
Yes, now.
They
connected to a Bluetooth. I
Okay.
don't know which one.
Okay.
We are not hearing Dr. Gladys.
Okay.
Okay. How about now? Can you hear me?
Yes, we can hear you now. Start.
Okay, so it was not
fast, please.
Okay, so the examples. Remember, I talked about George 2000 method of data analysis. So I am going to give you the examples based on these 4 themes. So I'm going to start with the first one.
One thing.
Okay.
One example in one of the themes.
Okay, so one example is indigenous, the Western scientific explanations for indigenous knowledge being unavailable but likely to be developed. So one example can be raised from one of the questions that says, what are the indigenous knowledge and practices that is carried out when a woman that has just given birth loses her child? And can you hear me?
Yeah,
I can hear you.
Okay, so one of the response given was that when a woman that has just delivered loses her child and she has an engorged breast, what they do is to get cabbage leaves and then wrap the engorged breast with the leaves, and she does that morning and night. So within few days, the engorged breast gets de-engorged. That means it flattens out. So now we can look at this from the West, although there are no scientific explanations for this, but we can actually draw out explanations for this in the light of osmosis. Now, as we all know, osmosis is the movement of molecules from a region of lower concentration to the region of higher concentration through a semi-permeable membrane. So from the indigenous knowledge perspective now, we can say the content of the engorged breast has a higher concentration. Then the skin of the breast goes for the semi-permeable membrane from the Western scientific perspective. Then the content of the cabbage leaf, we can compare it to the content in the engorged breast as having a lower concentration and having anti-inflammatory properties. So then for it to be able to de-engorge a breast that has been engorged, it means that there is a movement of molecule from the cabbage leaf into the breast that has been engorged, which satisfies the principle of osmosis. I don't know if you understand.
Thank you.
So,
it's okay.
Can I go ahead?
No, it's okay. That's enough.
Okay.
So, no, after the Babalawo answers my question, Dr. Olusegun will now. Okay. Yeah, it will be the last person to speak online. All right, the Babawo, please. Mr. Mustafa Biola, are you there? All right, let's have Dr.
Mustafa.
Yes, I'm here. Thank you.
Did you get my question?
Yes, I did. Let me quickly answer it.
Be very fast, 2 minutes.
Oh yeah, thank you for the feedback. Please note, I'm not a Babalawo, as I think I've said earlier.
Oh, I didn't know.
I'm not a Babalawo. Yes,
Okay.
I'm an affair researcher. I'm a mathematician.
All right,
that's what I do, so that there is no confusion.
Okay.
So the time frame for the mathematical within 10 or 15 minutes. So, but it's IFA numbers, IFA or any aspect.
Okay.
Yeah, we are focusing on the energy. The energy. My screen, but I don't know where. Okay, yeah. So that's what the. I could not go into details.
I think we will continue the conversation subsequently. Let's listen to Dr. Olusegun. Please allow Dr. Olusegun to speak.
All right, thank you.
Yeah, thank you so much, Mr. Mustafa. So Baba, so thank you for taking out your slide. So my question is just a quick remark to what Arojinle said. So, and I appreciate his comment. So because that is pointing to one key area. I'm a scholar, I'm a cultural studies scholar, so who's also interested in science, and I've written works on shams and amulets, rhetorics of science. So I've published and I continue to work in that area. But what I think every one of us is talking about here is the need for a meta language. So for us to be able to do all of this effectively, I think we need a meta language, and that meta language is calling for what we call institutional collaboration. University of Ibadan has scholars who are working. In fact, most Yoruba scholars from University of Ibadan, Unilag, and most of the leading scholars, Kolawolabi and Co. They are working on the meta language. I think, and the essence of me attending this meeting is that for those of us who are not in languages, for those of us who are not in cultural studies, who are purely science, scholars. So I think it is important for us to all collaborate with those in language studies, in cultural studies, to evolve these meta languages so that when someone is teaching about a particular concept, we are all using the same term globally across our different schools, maybe in Nigeria, maybe in abroad. So that is the essence of what I want to say, because again, when we talk about indigenous knowledge systems, I've said it, Yorubas are scientific, but it's coded more in their cultures and in their proverbs. For instance, loss of motion, why can't we take lala to mean matter? So why are we looking for different ways of defining Lala. Without someone he just said that. So that is also some loss. What is OFA? Magnetism. So we have all of these terms that we all can coin together. But the point is that when we work differently and we are not unified, so what we aim to achieve may not be achievable because we need that institutional collaboration. That's my point. Thank you all for permitting me. But I think let's continue this conversation. Let's exchange numbers. Let's all collaborate and publish papers together. That's the best way to do.
You have our emails in the book with you, Mr. Olusegun Soetan, and I'll be glad to hear from you. I'm the panel organizer alongside with my co-organizer, Mr. Iskili Ugbolan Arojinle, the popular animal documentary person on the internet. So I would love to get an email from you this evening. Then we will take it from there. Yeah. And also perhaps introduce you to our WhatsApp group. Mr. Iskili, could you round up the session? I've hijacked your role severally.
Well done.
Thank you, Dr. Milani. So I want to really thank us all, and the participants, the attendees, most especially Dr. Soetan. And like he said, I think developing a meta language will really help because we have all agreed that the Yoruba, or let's say African indigenous knowledge system, can really improve learning in different fields. But then at some point, we'll all need to come together and develop meta languages that we all can use so that whatever we say, whatever we call cell in Ibadan is what they call cell in Odogbolu, and it's the same in Ekiti. And so collaboration and communication, I think, over to you, sir.
So thank you very much. We are looking forward to see you tomorrow in our roundtable, a very powerful roundtable. Let me tell you about our discussants, and I don't want anybody to miss that roundtable tomorrow. It will be holding between 12:45 to 2:15 p.m. The first person is Dr. Tunde Adigbola, is African Language Technology Initiative. Dr. Taufik Adebayo, California State University, San Bernardino, is the one that does science in Yoruba. Let me snap that thing there. Snap over. Then we have Moshood Abib Abiola. He will be here live. Mr. Arojinle will also be here live. Olalekan Fabilola Masoyinbo, we are not sure whether he will be here live like we thought. And afterwards, we'll have a mathematics person teaching Yoruba in mathematics. Thank you very, very much, and see you tomorrow. There's also part 3 and part 4 tomorrow that will be taking place 3:45 to 5:30 and 5:45 to 7 p.m. I'm looking forward to the email that I will receive from Dr. Olusegun Soetan. So have a good night. Bye-bye. Thank you for your wonderful conversation. Thank you. Thank you. Bye-bye.
Okay.